let me tell you, I mean, I know some of you have done this because I've got the work already and I've marked it already, so I'm good with that. But I'm only choosing bite-sized tasks. This is the question 3. That was an extension question from yesterday's task, which everyone got right. Now, I'm guessing this Jack is throwing something at coconuts to try and knock them off at a fairground. And also, he's also worked out a probability for some reason that he is going to get a probability of 0.15, or rather relative frequency of 0.15 when he knocks over the next coconut. So if his probability of knocking over a coconut is 0.15 and he's going to have 40 goes, if you multiply 0.15 by 40, that's like saying 4 times 1.5, you get 6 coconuts. And that's really leads on to the next little bit. Now, just to reiterate, I mean, Henry's not here, but anyway, just to reiterate, doing tables in context is very helpful to the question. It's not just a list of fractions or percents. You can see the story behind it. So today's lesson is this, expected frequency, and it's been revisited again. So you don't need to draw that fat little git there or that stupid little penguin. Let's just do one together. So Brandon, me and you, since you are very manly and mature and sensible, at least in maths anyway. So the probability of the biased dice, oh, it's biased, lands on a 5 is 0.6. You'd expect about 0.16, which is 1 over 6 actually. So anyway, it's definitely biased. There's far too many 5s. Over half the throws are 5s. That's just weird. So how many times would you expect the dice to land on a 5 if I roll it 10 times? 10 times 0.6 is 6. Cool? 60 times 0.6. Well, that's basically 6 times 6 is 36. Got the idea? Not difficult. So you need to do question 1, question 2. Let's look at question 3. This spinner has 3 equal sections. How many times would you expect the spinner to land on the penguin? Well, if they're equal sections, please read that carefully. It means a third of the spinner is taken up by a penguin. I don't know why they didn't call it 1, 2, 3. I think they're just trying to be funny, but I'm just annoyed. So anyway, what's the chance of landing on a penguin? 1 over 3. What if you spin it 90 times? 1 divided by 3 times 90 equals 30 penguins. And that's all there is to it. And there's a beautiful question there, which is extension-y. Not very difficult, just read the English of it, really. So we've got Rob and Paul. They're both footballers, okay, and Rob's team, chance of them winning is 0.6, and the chance that Paul's team is 0.4 for them to win. Now, Rob's team play 30 matches, so Rob goes with that. And Paul's team played 35 matches, and that goes with that one. How many more matches did Rob win than Paul? I suppose you're going to work out how many matches they both win and then subtract. But I'll leave you with that. I mean, that's all there is to it. Please understand that those of you who are here with me now recognise that I'm not setting homework. These are small, chunky 5, 6, 10-minute tasks. That's all it is. That's all I require of you, because I know I can finish this course. Right? I can finish it. So I'm not going to heap stuff on you when you're spending far too much time in front of a computer anyway. So out of love and respect, I'm not going to be doing that. So all you got to do is exercise 2. Again, if you look at your show my homework, you see it there. Exercise 2, there's just 4 questions, 1, 2, 3 and 4. Don't draw anything, because there's nothing to draw. And don't draw the penguin in the spinner. It's just boring. All right.